Hi everyone. In this video, we are going to discuss about DevOps and DevSecOps. And in this video, we will see what really makes difference between DevOps and DevSecOps. So what all pipelines do comes in between those two terminologies. So what principles are aligned with those terminologies, which is DevOps and DevSecOps. So first, let's see what is meant by DevOps. And usually DevOps is kind of it's a primarily focus on, or we can say, collaboration and communication between the development and operations on between the teams, and it's mostly happen in software development and delivery process, which means like you are going to make a bridge a gap between development and operations by using the DevOps principle. In other hand, so what does it mean by DevSecOps? So DevSecOps is kind of principles of DevOps, and we are going to integrate the security on top of it. And this security will be applied on software development and delivery life cycle from the beginning. So we will see deep dive into those terminologies, what really makes the difference between DevOps and DevSecOps. Before that, I would like to take you through the what is mean by DevOps with the architectural diagram. So let's say example, this is one organization, which means like, here these two guys are developers and this is the end user. So what developer they usually do, they do develop the code based on the business requirement by using different stacks such as Java, Python, .NET, Ruby. So we have a number of stacks. So by utilizing the any one of a stack as a language, and they develop the business logic. And later they push the source code into the source code management. So in the market, we have a number of source code management. So best example is GitHub. So from here, our responsibility, which is the DevOps responsibility, is to make the automation to deploy this source code into the targeted environment, which is this orchestration. So usually by applying the DevOps principles, what happened, right? So we do communicate with the CI/CD tool in between source code management and the CI/CD tool. So CI/CD stands for continuous integration and continuous deployment and delivery. So this is the main automation is going to start from the starting, and it will take till the ending, which means this CI/CD tool is a tool. It will go and pick the source code from the source code management, and it will convert as a code as image. So while converting the code, we have a number of deployment strategies, which is package-based deployment, and we have a container-based deployment. So in this DevOps principle, we are going to discuss about container-based deployment. So in the container-based deployment, what happened? Whatever code was pulled by CI/CD, so it will convert the human understandable code into computer understandable, and it will paste into any one of the targeted web server or application server. In general, we can say it's a Tomcat or Nginx. So the CI/CD tool will go and convert this source code from normal human understandable to computer understandable, and it will convert as a image. So we call it as a container image. Sorry, just the image, not a container image. Yeah. So here we are discussing about container-based deployment. So what usually we do by using the CI/CD tool, we will go and deploy the same image into the orchestration tool, which means like we have a number of orchestration tools are available. If you don't want the orchestration tool, you can directly deploy your source code into any one of the any one of the container runtime. In the market we have a Docker, Containerd, and we have other tools also available. So you can go and run your container as a your code, and you can give access to the end user. So here the DevOps principles where it has applied, which means like from the start, like if the source code has came into the source code management tool from here, so we have applied the DevOps principle, which is it has to pick with the CI/CD tool, and it has to integrate the code, and it has to build, and it has to create the code as an image. So these all activity happens on CI/CD tool. So once it is convert this code as an image, and this CI/CD tool will go and deploy this image into the orchestration tool or any one of the container runtime. So this is how the entire pipeline do happens in a typical or normal DevOps principle applied on infrastructure. Which means once the developer has commit the code, the entire process will be start as automatically, and it will be deployed into the end user, or wherever the end user to access it, or end server, and it will available to the end user. So normally we use such type of environment to make automation. So we can integrate in a number of stages in between within the CI/CD. So I don't want to discuss all those things, because I just want to focus more into just DevOps principle and the DevSecOps principle. What does it really mean, and what makes the difference between those two methodologies? So everything is working fine, and we don't have any issues, because like we have automated the work from manual to automation. And once the developer pushes the code into source code management, so entire automation will trigger, and it will deploy into target server. Even the end user will go and access the website, and it will working fine. There is no issue with the this entire automation from the perspective of automation. But when you see in terms of security level, there is no security has configured in this entire automation, because while developers had been writing the code, they may use different types of versions, different types of dependencies, so it can be vulnerable. So even they may maintain the code as qualified as a quality, and they may not maintain the quality of the code, or they may use any one of vulnerable modules or vulnerable dependencies. So we need to find the loopholes where we have, which is vulnerabilities. So we need to check, is there any way, like by mistake developers has committed the sensitive information, or did developer keep any sensitive information in their source code. So we need to find those all the loopholes, because usually what developer do in the development phase, they do configure all the sensitive information in the source code itself, and as a username and password they committed to the source code management. So if they committed the source code management, it will trigger the automation, deploy into the end user. It will go and deploy into the targeted server, and the end user will access it. What if instead of end user, this website has been accessed by any kind of hacker, or any kind of person who wants to do some kind of wrong things with our website? So what he will do, it will go and check he will go and hack the website, and he can easily bypass the rules that developers has written, and he can easily get the user and passwords of your DB, or any resources which you used in your environment. So that's not a good practice. So we need to prevent those all mistakes which is happening from developers. That's the first thing. And the second thing, we want to find, is there any loopholes? Is there any vulnerabilities are present in our source code? So that's the main reason we need to integrate the DevSecOps into the DevOps principle. So if you have seen in the automation level, there is no any issue with automation. The entire automation is wonderful, and the whenever a developer pushes the code into source code management, it will go and automatically deploy into the targeted server, and end user is using the website. There is no issue. But the issue here is that we need to sanitize our source code. We need to sanitize our source code to prevent the vulnerabilities, to prevent the sensitive information. Is there any sensitive information has been mentioned in our source code, or has been advertising in our source code? Because usually developers may get they don't do commit, or they don't push the sensitive information along with the source code, but it may happen because developers may forget that they already pushed it. So we want to pick those sensitive information, and we want to tell the developer, saying that, hey developer, you have pushed the sensitive information along with the source code. So this is not a good practice. Go and remove the sensitive information. So we want to pick those type of issues on the entire in this entire automation. That is where we brought the DevSecOps concept. So let me go to the DevSecOps automation. So this is the normal DevSecOps automation architecture. I just have given few stages, because I just want to make you the what really makes the difference, instead of bringing all these stages or tool names in the architectural diagram. So even the same architectural diagram do follow the DevOps principle. So here we have the developers, and they do push the source code into source code management. But what happening? By following the DevSecOps principle, we have installed one pre-commit hook scanner into the developers local laptop. So usually developers do laptop or computer, or any kind of instance or any kind of thing to work on their own local area. So what we do in our DevSecOps principle, first we we take one pre-commit hook scanner, install on each developer's system. So what pre-commit hook scanner will do? So whenever developer wants to push his source code, so this pre-commit hook scanner will go and check the source code. Is there any sensitive information has been advertised or exposed? So if any sensitive information has picked up by the pre-commit hook scanner, and it will go and notify to the developer, and it will stop pushing the source code from local laptop to the source code management tool, which means any sensitive information or any vulnerability got found by this pre-commit scanner, which means like it may be a sensitive information or it may be a vulnerability. So this is how on a base level you can prevent the vulnerabilities, you can prevent the sensitive information get pushed into your source code management. So that's the beauty of by following the DevSecOps principle. But when I compare it with the DevOps principle, we haven't specified any way about the pre-commit hook scanner. So they have just written the source code into their local system, they pushed into the source code management tool. But by following the DevSecOps principle, because we need to keep security at each stage to prevent the vulnerabilities, to prevent this sensitive information get pushed into the source code management along with the code. So that's the first stage. Like on the base level itself, we have prevented and we have found the any vulnerability. So, or if you have found any sensitive data has been exposed, so you can this pre-commit hook scanner will stop over here itself, and it will notify the developer saying that, hey developer, this is the vulnerability I found, or this is the username and password I found. So this is not a good practice. Go and remove those sensitive information. So you have to rewrite the code again. So on the base level, we have built one good scanner or good security tool where it go and it find the vulnerabilities. So fine, no, this pre-commit hook scanner has given a green flag, and the developer pushes the source code into source code management tool. And as we know, like by following the DevOps principle along with the DevSecOps, so we have integrated the source code management with the CI/CD tool, which is continuous integration and continuous deployment delivery tool. So once your code have came to the CI/CD tool, so we do have a SAST or DAST or image scanner. So what is meant by SAST, which is static application security testing, and the meaning of DAST is a dynamic application security testing. So this CI/CD tool will go and call the SAST scanners or SAST tools, and it will scan the source code for finding the vulnerabilities. And you can ask me the question, hey, we have already done this activity over here. But why you are calling again the SAST tool over here? Because we do follow some standards, saying that we make sure this pre-commit hook scanner should be installed on every developer. But what happened if developer has not installed the pre-commit hook scanner in his local laptop? So for single time we can go and notify to each developer, but every time we cannot go and find whether this developer has installed it, the pre-commit hook scanner or not. That's why, for making sure, even if we missed over this stage or over this step, so we have installed SaaS scanners on DevOps automation level. So we have installed SaaS scanner on DevOps automation level, which means once the source code came into the source code management, it will pull by CI/CD tool and it will get built, and it will scan with the SaaS tools. So it will go and find, is there any vulnerabilities are present in your source code, or any sensitive data has exposed, or is there any chances to hack your database, or like SQL injection, cross-site scripting, cryptographic. We have a OWS API top 10 vulnerabilities. So that is how we are going to scan our source code with a SaaS tool, and we can find all the vulnerabilities over here. And we have another scanner such as a DAST, which is dynamic application security testing. So this is also one kind of security tool. It will go and scan your it will go and scan your website while it is running. So you can ask me what really difference between SAST and DAST. So SAST is a tool. It will go and scan your source code while it has not been deployed into your source code, or not deployed into the targeted server. Which means, like, you just barely go and scan your entire source code. But Dast is will go and apply on your website where it has already deployed into the targeted environment. Which means, so by using the Dast scanner, you can scan your website on live. Is there any possibilities that hacker can attack your website? So by utilizing Dast scan, you can go and go and scan your website as a live. So as we know, like, even in our DevOps, typical DevOps principle, or DevOps methodology, we know that we create our source code as an image. So for and usually if we go to the DevOps architectural diagram, so we convert code as a image, which means our enter code as image. So we need to scan that image also, because we are going to create a container, image. We are going to create a enter source code as image. So even this that image may have some vulnerabilities. So for that reason, we need to scan our image. So are there any sensitive information as exposed on your file that, but we usually use Docker as a container runtime. So, and for creating converting your Docker image, so you need to have a Docker file placed in the source code. So even we need to write your Docker file. So typically, we don't want to mention insensitive information or Docker file. But are there any chances that you have exposed your um, Docker file with any sensitive information like username and password? So even the base image that you are using, does it have any vulnerabilities? So these all places we need to scan our Docker image. That's why I have integrated this image scanner in this DevOps DevSecOps principle. So once the image scanner is done, and it will go and deploy into the orchestration. Typically, we use a Kubernetes cluster. But even we have, by following the DevSecOps principle, we can place one Kubernetes security scanner, because if you're deploying your source code as a container-based deployment and deploying it to the Kubernetes cluster, so you need to have a Kubernetes manifest files, which is Kubernetes definitions files. So even the Kubernetes definition file, you need to write it. So for that also, we need to scan those Kubernetes definition file, because it may expose any sensitive information on um, Kubernetes definitions files. That's why we need to scan all our Kubernetes definitions file, and that's the reason we have integrated the Kubernetes security scanner. So this scan, what it will do, it will go and scan all your Kubernetes definitions files, and it will give the report. Is there any vulnerabilities are present? Is there any sensitive data has exposed? So once it is give a green flag, it will go and convert as a container inside of your Kubernetes cluster. So this is how we can deploy your source code with securely. So once the source code has deployed into the Kubernetes cluster, so user can use uh, this servers whenever he hit the www.xyz.com. So that's the difference between DevOps and DevSecOps. So this is where the difference makes in between those two methodologies. Typically DevOps is like, just making the automation between development and operation. When it comes to DevSecOps, you are going to make sure security is everywhere at each and every corner to prevent the getting prevent the vulnerabilities free from your environment. And since we have been discussing about vulnerabilities, like, we have vulnerabilities of top 10, like open web application security, top 10 vulnerabilities. And we have a set of list, like we have a SQL injection and broken authentications and sensitive data explore, and XML like external entities, and broken access controls, and we have security misconfigurations also, and as I mentioned, cross-site scripting, insecure deserialization, and we have the using components the known vulnerabilities, like, if you wants to use any if you want to use any modules, but you already knew that this module was vulnerable. But even what generally people don't want to use the such type of modules, but somehow the developer have integrated those modules into the source code. So that reason we need to find those vulnerabilities. That's why this OWS like saying that using component with a known vulnerabilities also one kind of vulnerability. And insufficient login and monitoring, this is also one kind of vulnerability on top 10 list. So, like, these lists get updated in sort of years from the official OWS API. And this is all a major vulnerabilities do find in a runtime, skill injections. We have SQL, NoSQL, and OS, and LDAP injections do happens. And an injection flaws, or if you are using PHP, uh, attacker can pass or bypass the URL by passing any regular functions, or special keys. So this is where we need to find the vulnerabilities on application level, or source code level. So that's the really difference between the DevOps and DevSecOps principle. And I just brought the basic architectural diagram, and feel free to give your suggestions on this video comment section. And thank you for watching, and stay tuned. Bye bye.